Out of town, so she asked me to substitute this morning. Those that are registered for the seminar know the drill to initial or sign or whatever it is. Start that around. You can locate that. All right, well, thank you. Welcome, Dr. Simon Out. Assistant Professor in the Computer Science Department. That got his PhD from Princeton University in 05-ish, I think. And he spent time as a postdoc at the Intrusion Center at Duke. And he's been in faculty at Kansas State since then. I just learned, if you want to calculate the odds of this, it's a big number, that he and his host here today, Dr. Yao, we think went to kindergarten together. So do the math. That's pretty amazing. And they have known each other for a long time. They work in related research areas. And today he's going to present on some work he's doing in Intrusion.
Thank you, Cal. So can people back there hear me well? Okay, wonderful. Thank you very much for inviting me. I'm very glad to be here. This is my first time being on this beautiful campus on such a beautiful day. So I'm going to talk about is something that is still very much a work in progress. So I probably will not have a lot of results to show you. What I'm going to discuss is more like a methodology. So we call it an empirical approach. It's in some sense unorthodox. Typically when we start investigating a research problem, we want to think about what methodology we want to apply first. And then we try to develop the formalism and we'll apply it to some data and hopefully we'll be able to validate our model and methodology. Well, for this particular problem, which is intrusion analysis, we found out that it may be better off to start from the bottom up, from the ground up, to do some experiments. And based on empirical experience, can we build our model from that empirical experience? And hopefully, in the end, we can find the right theoretical framework for that problem. So let me first motivate this problem through a very simple example. This is a true security incident that happened in my campus network a couple of years ago. So about 4 or 5 p.m. during the day, just when people were about to leave work, our system admin noticed abnormally high network traffic on the campus network. That triggered an alert for him. So he suspected something was wrong in the network. So he looked at the net flow dump. You probably know what net flow is. It's basically just a recording of all the communication, source, destination, protocol, and port that happens, that can be seen in that border router or gateway. It does not have the payload. All it has is these pairs of connections. Well, he found out that there were a few Trend microservers. Trend Micro is an anti-malware vendor. The server from Trend Micro basically maintains up-to-date malware definition files for people to download. So some of those Trend Micro servers were communicating with known botnet controllers. The botnet, you all know what it is. These are compromised machines, zombies controlled by criminals to attack other machines. Well, that really raised a red flag for him, since those machines should not be talking to those potentially malicious IP addresses. So he would like to figure out what was really going on. So he sat in front of one of those machines, and he did something called a memory dump. So essentially, he examined the memory using some tool that he could get, and he found out that there were some seemingly malicious code modules in his operating system kernel. And he was not sure what those modules were, but he suspected that these were potentially malicious. More than that, he also found out through this examination, there were open IRC sockets on this Trend microserver with other Trend microservers on the campus network. So the IRC is Internet Relay Chat Protocol. It is used for messaging like MSN or even Skype, but it's also widely used by botnet to send command and control messages to the controlled zombie machine. So at this point, he concluded that all of these Trend microservers were compromised by an attacker. And actually, he kept this search through this open IRC channel. He was able to identify totally 12 machines that were compromised by a zero-day vulnerability. Nobody knew about this vulnerability until it was hit by this zero-day attack. So the reason I want to show you this story is, if you look at the train of thought from the system machine, just because he saw something suspicious doesn't mean that it's always going to be a bad thing. The biggest challenge in this whole reasoning process is that you are not sure whether it is really an attack or whether an attack has succeeded or not. So the biggest challenge is the uncertainty in data. So what do I mean by uncertainty? Well, if you look at these individual evidence separately, if you only, for example, have a net flow showing a trunk microserver talking to blacklisted IP addresses, so that absolutely means this machine is compromised? Well, it's not easy to answer because, number one, your blacklist of IP addresses may have false positives. Some machines may have been one of those botnet numbers, but it may have been cleaned up afterwards. And so the list may have false positives. Or somebody may be doing some research probing to one of those bad guys. So it may not necessarily be that it has been compromised. So even though this is a high alert, it's something very likely to be bad, but you're not sure whether it's really the case that these machines were compromised. Likewise, if you only see an IRC socket in that machine, what would that mean? Well, that could be a range of things. It could mean people using MSN Messenger, for example. It does not necessarily mean these IRC connections were used by botnet. Right? But the key here is, if you put all these pieces together, what do you think? Do you think these microservers were definitely compromised? So you have this net flow downstream that's talking to blacklisted IP addresses, and you also have this potentially malicious code module, and you also have these IRC sockets. Well, this is probably pretty much slam dunk. So these machines were taken over by the attacker, and that's what the human reasoning was. So he decided, based on these evidence and his thinking, that these machines were compromised, and he took them offline. But unfortunately, it took him about 3 or 4 hours to do all of these data gathering and analysis and response. So he went back home maybe at 11 or midnight at the time. So our goal in research is to see if we can help design some automatic reasoning methodology that can help a human, as they like the guy here, to do it more quickly and easier way. So as I mentioned early on, we like to apply an empirical approach to handle this uncertainty challenge. Well, there are a number of reasons that we decided upon taking on that task. Well, first of all, there is actually, even if I said here, there's a lack of theory or good tools in practice, but in academia, there's no lack of theories about reasoning under uncertainty, especially from the artificial intelligence recently in the last 40, 50 years. So why didn't we start with one of those theories and apply it in this talk? Well, the difficulty is, to make those theories work, you typically need to have 2 things. Number one, there needs to be a knowledge engineering process to build a particular reasoning model. That typically involves some logical structures among various hypotheses and observations, and you have to build this logical structure first. And this is not clear to see how you can do this for cyber attacks. People have applied this in other problem domains like disease diagnosis, but human diseases